In this video, we'll talk about how we can find asymptotes and wholes. So I want to begin with a key fact. So a factor that makes the denominator of a function equal 0 gives us one of two things. So it can give us a vertical asymptote. Sometimes it can give us a vertical asymptote. We'll write that E better. A vertical asymptote if it does not cancel completely. Okay, and it would give us a whole if it does cancel completely. So if it does cancel completely away on the denominator. Alrighty, so that said, let's do some practice questions. So let's identify the vertical asymptotes and the wholes of the following functions. So f of x and we have g of x, and they're very similar looking. The only difference is I have minus 4x on the top of f of x, and that's minus 3x on the top of g of x. So to be able to use this key fact, I need to figure out what factors of the denominator will cancel completely away, if any of them. So let's factor. So if I take my function and I factor the top, I get x times x minus 4. And the bottom is the difference of squares. So that'll factor as x minus 3 times x plus 3. And now that it's factored, I see that nothing actually cancels. So if I look at my key fact, when there's a factor on the bottom, like x minus 3 or x plus 3, that does not cancel completely away. It's going to give me a vertical asymptote. So we are going to have a vertical asymptote at the values of x that make those factors equal 0. So for x minus 3, what makes that equal 0 is x equals 3. And for the x plus 3, what makes that equal 0 is x equals negative 3. So we have two vertical asymptotes here. Okay, but there were no factors on the denominator that did cancel completely away. So this function has no wholes. So no wholes. Let's look at part B now. So with B, let's also factor this. It's going to be very similar. I'll get x times x minus 3 on the top, and on the bottom, I get a difference of squares still, x minus 3 times x plus 3. And if I think back to my algebra pre-calc review, one of our earlier videos from the course, I could cancel the x minus 3's on the top and on the bottom, and what we're left with is x over x plus 3. But I can't forget that because I cancel the x minus 3, there's a domain restriction that I don't want to forget about. Because when I simplify a function, the domain of it better not change. And if I look back to the pre-cancelled form, x definitely is not allowed to be 3, because it would have made the original denominator be 0. But when I cancel it away, when I cancel that factor, I can't see that restriction anymore, that x is not allowed to be 3. So I need to state that. So this is true as long as x is not allowed to be 3. I don't need to explicitly write the domain restriction that x is not allowed to be negative 3 from this other factor, because I can still see that in the denominator. I can still see from the denominator that x is not allowed to be negative 3. Okay, so that was a little bit of review. Okay, but now because we have this cancellation, let's write down our vertical asymptotes and wholes. So vertical asymptotes come from factors. We can see them from factors on the denominator that didn't cancel completely away. So the x plus 3 did not cancel completely away. So that would give me x equals negative 3, because that's what makes that factor be equal to 0. And for the wholes, in this case there's going to be one whole. It comes from the factor on the bottom that did cancel completely away. So that's the x minus 3 factor. So what makes that be equal to 0 is x equals 3. But a whole should be a point on the graph. How do I get its y-coordinate? So the way I'm going to get the y-coordinate is we need to plug x equals 3 into something. We are going to plug it into the simplified form. Simplified form to get the y value. The technical way we'd find the y value of the whole is you take a limit, you take the limit as x approaches 3 of your function, but when you take the limit, you'd first plug in, and plugging into the original would give you 0 over 0, which would mean we'll simplify, we'd do this cancellation, and then we'd plug into that simplified form. Okay, so I'm essentially going to skip that because we've already done the simplification, and I'm just going to go ahead and plug into that simplified form. All right, so that gives me 3 on the top, on the bottom 3 plus 3, so this is 3 over 6, which is 1/2. So my whole as a point is at 3 comma 1/2. All right, so that is how we find vertical asymptotes and wholes, at least when we have a function that's a rational function, when we have polynomials on the top and on the bottom. There are other ways a function could have a vertical asymptote, like we know, for example, ln of x. This is a vertical asymptote. This graph looks like this, and that has a vertical asymptote at 0. Okay, so we also want to be aware of other types of functions that we know and where their asymptotes lie. Okay, so what I want to end this video by discussing is, what about horizontal asymptotes? So recall that we find horizontal asymptotes by taking limits. We take the limits as x goes to infinity of our function and the limit as x goes to negative infinity of our function. And if either of those limits ends up being a finite number, we have a horizontal asymptote at that finite number. So potentially, if both of these limits were finite numbers, we could have 2 horizontal asymptotes. So in terms of our goals for this section, we finished goal 2, talking about how we find wholes and asymptotes of a function.